Last question of this paper, question number 10. The diagram shows the point A and B lying on the curve with equation y is equal to 9x minus 2x plus 1 power 3 over 2. This is the equation of the curve. These are the points A and B given on the curve. This is the curve. These are the points A and B. Equation of the curve is given. First part of this question is part A. Find the coordinates of the maximum point of the curve. Maximum point will be this point on the curve. We have to find the coordinates of this maximum point. So far, to find the coordinates of maximum point, gradient will be 0. For maximum point of the curve, gradient will be 0. First of all, we will find the gradient of this curve. Equation of curve is y is equal to 9x minus 2x plus 1 power 3 over 2. Differentiating with respect to x, we get dy over dx. Differentiation of 9x is 9 minus 3 over 2 power comes down before 2x plus 1. 3 over 2 into 2x plus 1 power 3 over 2 minus 1, that is 1 over 2, power 1 over 2 into derivative of the inside of the bracket, that is 2. The derivative of 2x plus 1 is 2. Cancellation. Now we get dy over dx is equal to 9 minus 3 into 2x plus 1 power 1 over 2. This is the gradient expression. Now for maximum point dy over dx will be 0. Dy over dx is equal to 0. So we are putting this expression is equal to 0. 9 minus 3 into 2x plus 1 power 1 over 2 is equal to 0. Rearranging it, 3 into 2x plus 1 power 1 over 2 is equal to 9. Dividing by 3 each side, we get 2x plus 1 power 1 over 2 is equal to 3. Now squaring each side, we get 2x plus 1 is equal to 9. From here 2x is equal to 8, x is equal to 4. This is the x coordinate of the maximum point. Now we will find the y coordinate. Putting this value of x in the equation of curve, we get the value of y. So we get y is equal to putting the value of x is equal to 4. 9 into 4 minus 9 power 3 over 2. Now this becomes y is equal to 36 minus, by calculating 9 power 3 over 2, we get 27. So we get y is equal to 9. So coordinates of the maximum point 4, x coordinate is 4, y coordinate is 9. 4, 9 are the coordinates of the maximum point. The next part B of this question is verify that the line AB is the normal to the curve at point A. Line, we have to verify that line AB is normal to the curve at A. This point is point A. We have to verify that AB is a normal to the curve at A. So this line will be first we draw the tangent. This is the this line is a tangent to this curve at point A. Now this is a normal AB. If this is normal, then this angle will be 90 degree. We have to verify that this AB line is a normal to the curve, normal to the curve at point A. Now, since AB line and this tangent are perpendicular to each other, so the product of their gradient must be 0. Suppose gradient of tangent is m1 and gradient of AB is m2, then m1 m2 must be equal to negative 1. So for this, first we find the gradient of tangent. Gradient of tangent, we have already found the gradient of tangent in the part A. Gradient of tangent dy over dx we have already found in part A, that is 9 minus 3 into 2x plus 1 power 1 over 2. Now at point A the coordinates are given. Coordinates of point A are given 1 whole 1 over 2 x coordinate, 5 whole 1 over 2 is the y coordinate. So at we are using this value of x coordinate, that is 3 over 2. We will find the numerical value of the gradient at this point. So at x is equal to 3 over 2, gradient will be 9 minus 3, 2 into 3 over 2 plus 1 power 1 over 2. Simplifying it, we get 9 minus 3. Simplifying inside the bracket, we get 4. 4 power 1 over 2. Simplifying, we get dy over dx of the gradient will be 3. Simplifying it, we get dy over dx, that is the gradient of tangent, is equal to 3. Now we will also find the gradient of normal. This line is normal AB. To find its gradient, we will use the gradient formula because both the points are lying on this line. We will use here gradient formula y2 minus y1 over x2 minus x1. Gradient of normal gradient of AB. Gradient of AB formula y2 minus y1, 11 over 2 minus 7 over 2, y2 minus y1 over x2 minus x1. We get 2 over negative 6, that is negative 1 over 3. So negative 1 over 3 is the gradient of line AB and the gradient of tangent is 3. So we are using this concept M1, M2, M1, M2. If we are taking the gradient of tangent M1 and gradient of AB minus 1 over 3, multiplying we get 3 into minus 1 over 3, that is equal to negative 1. This shows that AB line is a normal AB line. So since the product of the gradient of these two lines AB and this tangent is equal to negative 1, so we can say that AB is a normal to the curve at point A. AB is a normal to the curve at A because this line AB is uh, making an angle 90 degree with the tangent, so AB is a normal to the curve at this point A. This is verified. Now part C of this question, find the area of the shaded region. This is a shaded region. Look at the diagram. This is a shaded region, or clearly this shaded region is bounded by this line AB. Shaded region is bounded by line AB and this part of the curve. So when the shaded region is bounded by a line and the curve, formula will be, when the shaded region is bounded by line and the curve, formula will be y2 minus y, area, formula for area integration of y1 minus y2 with respect to x. This is formula for area when the shaded region is bounded by the line and the curve. So we need here the equation of the line and the curve. Equation of the curve is already given, but we need equation of this line AB. We need the equation of this line AB. To find the equation of line AB, we need gradient. We have already found, that is uh, minus 1 over 3. This is the gradient of line AB, minus 1 over 3 we have already found. Now we are taking a point. Now we are taking this point A, from which the line AB passes. We can take any point, but we are taking point A and the gradient is negative 1 over 3. So first we will find the equation of line AB, equation of line AB, y minus y1, y minus y coordinate of point A, that is 11 over 2, y minus y1, gradient is negative 1 over 3, x minus x coordinate is, that is x coordinate of A is 3 over 2. Simplifying it, we get y is equal to, we are simplifying it, and we get y is equal to minus 1 over 3x plus 6. This is the equation of line AB, and this is the equation of the curve. So we are using here this formula, y1, integration of y1 minus y2. We will integrate y1 minus y2 with respect to x. So area will be integration of y2. We are taking the equation of the curve y2 and the equation of the line we are taking it y1. We are taking the y of the curve is y2. So it will become 9x minus 2x plus 1 power 3 over 2. This is y2 minus y1. Y1 is minus equation of this line. Y1 is minus 1 over 3 x plus 6. We will integrate it with respect to x. Now, first we will simplify it, then we will integrate. We are simplifying before integration. 9x minus 2x plus 1 power 3 over 2 minus plus this minus and this minus is become plus 1 over 3 x minus 6. Now integrating, first further simplification, collecting the like terms. 9x is x term and the other term is 1 over 3x. Adding these two terms, this becomes 28 over 3 x minus 2x plus 1 power 3 over 2 minus 6. With respect to x, we are integrating it. 28 over 3x, integration of this will be 28 over 3 x square over 2 minus 2x plus 1. We are adding 1 in the power, that becomes 5 over 2, same as in the denominator, 5 over 2. Now in the denominator we will multiply by the differentiation of inside the bracket, that is 2. 2x plus 1, differentiation of this is 2, so we write here 2 and the integration of 6 is 6x. This is cancel out, 2 is cancel out. So finally we get 2 is also cancelled out with 28. This here it becomes 14 over 3. So after simplifying we get a is equal to, just we have to apply the limits. For limits we are making two lines, lower limit and upper limit. We will write here in the bottom lower limit, in upside and the upper limit. Now what are the limits? Point of intersection of the line and the curve will be the limits. Clearly this A point and B point are the point of intersection of the line and the curve. So we will take these points as the limits. We will take only the x coordinates. X coordinate of point A is 3 over 2 and x coordinate of point B is 15 over 2. So we we are taking these x coordinates as the limits. We write here the limits 3 over 2, lower limit, upper limit is 15 over 2. First we will simplify it, then we will apply the limit. Simplifying, we get 14 over 3 x square minus 2x plus 1 power 5 over 2 divided by 5 minus 6x. Now we apply the limits. 3 over 2 lower limit, upper limit is 15 over 2. Applying the limits, first we apply the upper limit, that is 15 over 2 in place of x. In place of x we are putting 15 over 2. We get 14 over 3 into 15 over 2 square minus 2 into 15 over 2 plus 1 whole power 5 over 2 divided by 5 minus 6 into 15 over 2. This is the upper limit right here, minus lower limit. Lower limit is 3 over 2. So it will be 14 over 3, 3 over 2. In place of x we are putting 3 over 2 square minus 2 into 3 over 2 plus 1 whole power 5 over 2 divided by 5 minus 6 into 3 over 2. We have applied the limits. Now we will simplify these terms and we'll get the answers. Simplifying it first, it becomes 14 over 3 into 225 over 3 minus 16 power 5 over 2 divided by 5 minus 45. This is the upper limit, minus simplifying these terms which are where we have applied the lower limit, it becomes 14 over 3, 9 over 4 minus 4 power 5 over 2 divided by 5 minus 9. Now we will simplify further. We get in decimal places because we have to give the answer. Put up to 3 significant figures. Simplifying these and getting the answer in decimal places. So we get 262.5 minus 204.8 minus 45, upper limit minus lower limit after simplifying 10.5 minus 6.4 minus 9. Now For using calculator here, we get the final answer is 17.6 unit square. This is the required answer. This is the area of the shaded region. 17.6 correct to three significant figures. This is the answer.